Hi everyone, welcome to New Breakpoint, Microsoft's digital event series designed for developers by developers. I'm Michelle Sandford, the Developer Engagement Lead for Australia, New Zealand and Asia. We go live on the second Thursday of every month, and if you're joining us live, drop your questions into the chat because we'll answer them as we go. New Breakpoint has expanded across Asia Pacific, and today I'm joined by Arnauld Lheureux, joining us from Singapore. Arnold is a global black belt, which I always think is a super cool job title. And today we're talking about something every dev team is grappling with right now. How do you actually ship with confidence in an agent-powered world?
Arno, why don't you tell us a little bit about your role and who you are before we start?
Absolutely. Thanks for having me, Michelle. It's a real pleasure to see everyone watching us today. So I am a part of GBB, as we call it, a global black belt, and my title is like Chief Development Advisor. And behind this is really probably one of the coolest gigs I had at Microsoft in the last few years, because I get to talk every day to developers, head of engineering, CIOs, and CTO, and so all very smart people that see AI coming into their job and transforming the way they build software as their everyday job. So this is really, really fantastic for me to be able to see them, work with them, accompany them through this change, and advise as much as I can.
Fantastic. So you framed this episode around a pretty strong idea: treat the spec as the product, let the agents do the heavy lifting. What was it that broke for you? What changed that led you to this mindset?
Well, I think it all started one year ago. Now we are recording. It's 2026, and remember 2025. It was the rise of the agent, and we all started to play with it, and saw that it was allowing us to do really interesting stuff. And then came vibe coding, and then it was a fantastic era. We were just looking at things, and it all looked like magic. Like things get implemented, things start to work, until you look at the details, and you see that actually the AI was filling the gaps the way it could, and if you don't look it too much into the details, it's not very reliable sometimes. So I think I think it's fair to say that.
I think I would say sometimes it's reliable, sometimes it's completely rubbish, and and sometimes it's in between. But if you're paying attention to it and guiding it properly, you're going to have a much better end result than if you just give it, a very vague description.
And that's how we do it. As a human, we give it a task, and the AI will try to do what it can to fill it. And I've seen a couple of times you were like, oh, it's compiling, it's looking well, and I say, yeah, but in this test actually you just put a filler to do, and then you didn't do anything. And then they go, oh yeah, sorry, no, I can implement it for you. And it's like there must be something that we can do to actually explicit everything. And making sure that the AI goes through in probably a little bit more deterministic way. So there is that problem that we saw, and there is also, the line of building software is just creating a long process where you have the business that wants to achieve something, then you have a set of people working, and every step of the way we're losing the intent. So the idea is, how can we keep the intent with a high fidelity and augment it every step of the way? The AI can help. We can develop on that, but that's basically the idea of spec-driven and intent development, right?
Yeah, actually, when you phrase it like that, it seems like that's the same problem that we've been having for 20 years between what the business wants and what the technical teams implement and what the project manager thought. It's all about communicating clearly the requirements and the spec, I guess. So
Totally, yeah.
let's get a little bit more concrete then. So in this episode, you're going to break down what actually makes spec implementable for agents and not just readable for humans. And when you look at a spec and think, yes, an agent can work with this, what are you looking for?
Well, first thing first is to have an approach which, always start a general with AI, and then start to go down and narrow things down. So, and AI will help you in that process. So it's really good to start from a very generic discussion, a high level vision of what you're doing, what you're trying to achieve, what you're trying to build. So making that intent very clear, and then going to break down slowly into that, and use the AI in a way that it allows you to go and break down those details. So that's what we do with SDD is like making sure that all the gaps are filled with LLM. All the things are disambiguated. So you make AI actually ask you questions. Hey, you told me you want to do this, but do you actually want to do this or that, or what's your choice? So you can go through this iteration. And what's really fun is sometimes you have the answer. Sometimes you say, I don't have the answer. Maybe ask me more questions and we will find the answer.
Mm.
And what's good, when you're in a SDD process, is all this questioning, all this interaction you had with AI. If you do your agent correctly, they will keep track of that. And if you think about it, uh, that's actually the most difficult part. If you look at a code base that's been done 20 or 30 years ago, and sometimes you look at it and say, what were the guys thinking? What were they trying to achieve, right? So having a track of why they did that, AI keeps a very good track on that in the memory of it, so you can ask it to put it really well into the specs. So start well and use AI to fill the gaps, and then don't reinvent completely the whole life cycle, right? You're still going to work on PRD document, on all the guardrails that you want to inject into it. It is not all greenfield and reinventing the wheel.
Mm. So really you're emphasizing things like clear outcomes, non-goals, edge cases, acceptance criteria, smallest testable slice. Which of these is most commonly missing in real-world teams?
All of the above.
Yeah, can be any of them. Yeah, depending on the team, right?
But
Cool.
so in that process, what I usually engage with developers or with head of engineering, that's actually the question I ask them. What's not working? What's the most boring thing and annoying thing that you're doing in your current work? And let's design an agent that will do it for you. So that's really how I turn the question usually, because I jump from one customer to another, and sometimes I have no idea what they're doing. I have no idea of the technical stack. But in the job, it's like asking simple questions like, what's your really your pain point, and let's try to solve it together. And actually, one of the very things I observe a lot is people are hesitating. Like, oh, I'm going to write an agent. How do I do that? And I'm like, well, just ask an agent to write the next agent. So I'll show you in a bit in a demo, but the question is, hey, I want to change this process to include that and that. It's like, well, just ask Copilot to build that agent for you. It's not that easy. It's not that difficult, and it's super easy to ask it to do it.
No, I used to have a lot of anxiety over things that I didn't know how to do because something in my crazy brain tells me I should know how to do all of the things. And if I don't, then I'm dumb. And it has taken a lot of that anxiety away because indeed, as you say, I don't know what to do. I just ask Copilot, what do I do? How do I do it? All of those things that I would get stressed about, the infrastructure side, the security things, it will explain them to me and it will tell me what I need to do step by step. Some of the things it can do for me, but it will explain what it's doing as it does them. And it's just such a huge comfort to me. So now when someone asks me something I don't know, instead of panicking, I just think, I'll just ask Copilot first and then I'll answer them.
Yep. Yeah. I use that often to prepare for a meeting as well. It's doing any part of software development and not just the coding, so you can ask anything about it. Yeah.
I love it. So initially GitHub Copilot was you could only ask it about code. You couldn't go wider. Whereas now you can really ask it about anything. And, it goes a lot wider than just the code part of your project. And so, yeah, I feel like it's my best friend. We have so many conversations that teach me things, but validate things in my brain, like you were saying earlier. Okay, so if a team wants to try this, what is the safest place to start?
So I think we all have our repo that we are familiar with, we're working with. So I think a good way to start onboarding is start playing there with Copilot and get familiar if you haven't done so. Usually when I do onboard a repo, I just do create a custom instruction. So it analyzes, it goes through all my content, and I already have some kind of a first agent that will do some guidelines and way to operate on my code base. That's what we call the long live instructions. That's instructions that are going to be applied all the time. And then I think the usual process that we see here is create your agents, try to experiment it. You just now have a really easy button in VS Code where you can just create a custom agent. So just start there, see how it works, how it doesn't. And usually we start in the prompt. So start asking questions, see what works, what doesn't. And then once you have a good understanding, I mean, you could try as a human to recap the step and do that, but you can as well, in part of the conversation, like, thanks, that's what we achieved, is what I want to do. Now, can you please create a custom agent for me in the .github/agents folder for me to automate this step further? And I don't want to be to look into too much details, but I can show you something I was doing a few days ago, for instance. So maybe I just share my screen quickly.
Yes, we would love that.
Okay, so look here. I'm looking at something that I've built many years ago. It's an open source framework around Terraform. It's called Azure CAF provider, and it does one thing. It does naming convention for Azure resources. So basically, you give it a name for any resource that you want to create on Azure, and it will produce for you a name that is compliant with the Cloud Adoption Framework recommendation. So, putting a slug in the name, putting different part of the name, having a regex to clean, because an AKS cluster or a VM, they don't have the same naming constraints. So that's a provider we created for Terraform for doing that. And one of the really painful activity that we had was to create, if we look in the past, a new entry for this file, because we need to basically look at Microsoft Doc, we need to look at the API specification, we need to look at CAF recommendations. So it's a lot of things, and it's not very complex, but it takes a lot of time. So what we were doing is we were like, okay, when I check if a resource is correct, or when I want to discover a new resource, well, what you need to do, you need to use GitHub MCP server to parse the Terraform provider for this. Then you can use the API of the provider. You can use the Microsoft Docs MCP. You extract the name, and then you go through the process. All of that, I mean, no developer in the world do that thorough description of what an agent does. So actually, this is how I created this agent. I can look in the history. And you can see that I had a lot of interaction and disagreement with Copilot. You can see here, I need your help writing an agent. I want this agent to be able to get resources from Azure API definition, MCP server, Microsoft Doc, Terraform provider, analyze the resources to find the resources missing in a naming provider. The agent will create a report of the resources and then may be able to delegate a task to the name check agent or sub-agent to implement the missing name. So now it created that agent for me, and we had a bunch of interaction. This agent is here. That's the one I was showing. So now I have started to automate something that's really a painful usage of my time. And now I can just consume that here. I have my own agent that I created, discover resource or check resource. So when I want to complete a task, for instance, I can look at something missing in the provider, and I have my list here. So here you see, I just put check resource. I just put the name of the resource, and it will know automatically what it has to do because I put automatically inside this agent, and it's going to look inside the tasks that it need to do here. So that's always a way I love to use. Be iterative with the tool. Ask the agent to help you in the process. You can see that it actually is following the steps that I put into that. And you can see that now it created the 7 to-dos to delegate these tasks. And in those to-do, we're leveraging here all of the things that we have in GitHub Copilot. So we have the agents that is called here. You have the skills that are dedicated specific tasks. So here I have a task which is to build the provider. Here I have a task to do the Terraform mock testing with the Azure RM provider. So I don't have to provide my Azure credentials. So here we're still now in the process of solving issues with agent. So that's for me a fundamental aspect. When you start with Copilot, start to show that you're solving problem. So the team love it. The team learn how to be experimental on a code base that they know. So it brings them advantage right away from the job. So always thinking about that. And of course, historically, you may remember the first thing that we saw with Copilot was documentation and test. Because I know no customer that loves to do documentation, no developer that loves to do that, and no customer that is happy with their testing. You probably see the same developer. Feel free to to say otherwise if you met some. So that was the two first one. But now always go that and think about create your agent to solve your problem, however complex they might feel. Just have the interaction with it and just iterate on it. So be super experimental. I see also a lot of customers that they are just stopping at the first prompt and say, "Oh no, it's not working." Yeah, it's okay. Let's iterate. Let's ask it more questions and learn how to make it better. And just maybe I'm talking too much, but just one of the things I love as well with that, I see a lot with a very successful customer using GitHub Copilot in the enterprise. It's a cross-pollination of the different team. I see now the web team working with the testing team, working with the backend team, with the API team. All of them sharing best practices on how to write their agent, how to write their skills. And now they're like, oh, let's work together on automating more of the stuff so it can be easier and we can do more interesting things together. So then that was really something I see quite a lot nowadays.
Are the product managers clearing down the backlog by assigning tasks that have been outstanding forever because they didn't have the high enough priority, then assigning those to like a GitHub coding agent to resolve the backlog instead of having to wait for a developer to be free to do it? Are you seeing that?
That's the place where it's honestly most helping, and I see that as an open source maintainer. I think all of us that did open source, we all experiment something that it is a tough job. It's super complicated to do. It requires a lot of energy, a lot of work. So managing the backlog, managing this kind of stuff is really a place where Copilot is able to help really in a fantastic way. And I'm not going to take any demo. And I'm not going to take any too complex demo here. I'm just going to show you, Michelle, the repo where this provider I was showing, where it lives. It lives here. And sometimes in open source issues, we all know what it looks like. We see that, okay, I'm going to take just any here, and we say, hey, add support for this resource, this resource, this resource. Thank you. And that's it. And sometimes you may find somebody able to pick it in the community and start working on that. But now, what we've done is that, okay, Arno just assigned Copilot to these tasks 2 weeks ago. And here you see it's a very standardized repo, very simple repo. It's Golang, it's fetching a couple of resources, etc. So here we specify that in the configuration of the coding agent that it can use this MCP server, this thing, and these others. I can totally customize that. And we can see that, okay, Copilot was able to submit a pull request in probably a few minutes here. We see that, okay, it produces like a different part of the code. I think what's important also for engineers and our enterprise customer is the visibility and the traceability of what has been done. So you always be able to see, okay, it did that task, it did that operation, and you can see everything that has happened in the meantime. You see that, yeah, it did its job, is creating a test directory, it created a test for that particular aspect. And as you can see on the left-hand side of the screen, I'm quite fan of this. As an open source repo maintainer, there's many tasks I assign to it directly to address those depths, so those things that stay forever on the backlog. It's not that you don't want to do, it's just taking a few hours, but now it's just a matter of minutes, and you just review and approve.
Fantastic. It's great to see that like live in action. So once the spec is solid and the next step is translating it into agent work, this is where a lot of teams stumble. How do you break a single spec into high quality agent tasks without losing coherence?
That's the good question, the $1 million question. That I wish we had a universal answer for that, for sure. But there's two way around it, right? At least for me, you could be working on adding level of inception. So as you know, once you started to create an agent can call another agent, or you can delegate on simpler tasks. Like an agent will have simple skills, so you have a strong decomposition, and you have an agent which is more role-based agent. And in the instruction, you say, act as an Azure architect. As a good Azure architect, you will do a draft of the command for Bicep or Terraform to deploy that. As a good architect, you will review and do that. You will do the architecture diagram. You will review all the steps. So you can basically augment and add the capabilities in your agent. So that's a good way to add the know-how and an expertise on the code. And this is fine because this is something that we are going to reuse later. When we start to stitch things together, this is where we start to use an SDD approach like full steam, where we really want to capture everything into the spec, and then the implementation stage, let's say, of the implementation of the spec, which comes very last in the development stage. It will benefit of those agents that you already know, that you already build, that will make maybe the code compliant with your enterprise practices, with your patterns in the organization, with your web standard, for instance. So it connects and uses all the definition of the standard at some point. So all of these things, it's a good foundation that engineer can leverage day zero. And then on the way to creating a fully automated software development lifecycle, we're going to reuse it. So now it comes the part where really we use the glue with the SDD, which is automating all the creation of the software development lifecycle with the tools. Maybe not to make it too abstract, I can show you a little bit how it works with SpecKit.
Yes, that would definitely help me. Yes.
Okay, so just a good place to get started is there, github.com/github/SpecKit. It's there. It's an open source project. It's really cool because you have so many experiences I really love there. To me, what's most exciting is the issues, because you see so many things of people using it, people want to enrich it and add stuff. So it's really cool. But basically, you install this on your machine with the commands that you see here, UV tool install, specify, whatever. And then you create a new project with those commands. So maybe we can just start here. And here I can just do specify init demo 22. That's my 20-second demo of SpecKit, let's say. And here you see that we are working on other AI assistant. The right answer to this question here is Copilot. And then you see that I'm running on a Mac in my machine right now. But of course, if I'm running on my other machine, on my Windows machine, I can run that on PowerShell. But here I'll put SH. And here it's actually very interesting. You see what it's doing. There's actually not much magic happening here. It's just that inside the repo that we, the directory now that we created, what it did, it just got the template from the GitHub repo and it extracted it and it's deflated it into my environment. So now it's telling me, hey, go into this directory. So cd demo 22. And then you can see that, okay, the repo is already initialized for Git. So I'm ready and I can just do code insiders dot. Here it puts documentation, but I mean, who reads documentation, right?
Well, the Copilot reads the documentation for me.
Exactly. So why would I?
It gives me the TLDR.
Yep. Give me just what I need to know and bother with the rest yourself. So you see now we created an empty project, and in this empty project, there's a couple of directories that are here to determine my ID settings. Here we see that we have a .specify, and it contains actually a set of scripts. That's where the question matters. So if we're on shell, here we have the shell script to do a couple of stuff. The utility function, if you'd say. And here is a couple of templates. So basically, when you're going to use SpecKit, it's going to fill those templates for you. And it's really important when you want to start to customize your dev lifecycle, because you see that, okay, this is a template for an implementation plan. This is a template for a spec. So here, a user story, this is how it looks like, a user story and a user scenario. A user story and a user scenario, this is how it looks like. They should be prioritized, a user journey ordered by importance. So that's exactly how we want it to be documented. I have this there with the priority given, the example. So you're forcing the coding agent to go into a particular way of operating. And for me, this is really where the shift is super important. As you mentioned before, Michelle, remember, we were used to ask questions to Copilot, and he was our best friend doing that. But now you have an incredibly powerful engine to make it do basically whatever you want to build software, whichever way your enterprise is doing. So those are templates, but you can totally twist it to your organization. We'll come back to that later, but I have many customers say, no, look, Arno, this is not how we create software. We must start with this step, this step, this step. And I'll say, okay, let's use Copilot to modify this template. And of course, we need to meet somewhere in the middle, because we're not going to have to go to a company and say, oh, yeah, it's Copilot's going to change everything absolutely in the cycle. There's always like, it must conform to some way of doing software. So we help to enrich that, codify that, and make it work for every company with some things that are, however, still a set of best practices that we have. So you see how it's all my templates. So the magic happening in I would say SpecKit, as we show the example of SDD, is that is a set of scripts, my utility, a set of templates, and here a set of agents and prompts. So basically the prompts are very simple. They're calling the agent. And it's just for a very simple compatibility task, which is now you can say slash SpecKit constitution, for instance, and you know, a slash command, it's coming from the prompt. So historically, when we created SpecKit, there was not really agent, a proper implementation. So we were just calling prompt. So just for backward compat, we kept that. So in the SpecKit constitution, but actually it's the same thing. If you do that, then if you see add the agents here and you consume them via the box that is here. So remember, I'm here. I see in my GitHub here, I have the vanilla agent mode, edit, ask, and plan that we know. And here we are entering in the world of a specified agent to do a specific task. So when I click spec kit constitution, then actually I'll be executing and entering the execution mode, which is to define the constitution. And okay, long story short, but constitution, as you see here, is all the things that are non-negotiable principles of your dev lifecycle. So it's really what you do initially to say, okay, I'm going to work and create a project to do that. We're going to manage it using Kanban. We're going to automate this thing. We want to do this and this. So really the foundation and the minimum things that we want to put here into this. So if I switch to the mode spec kit constitution, I'm capturing the constitution and it's going to ask me question and behave as a, it's hard to say, it's weird to say that, but as a constitution specialist, but that's really the way it's going to behave. So, and you see that it's going to collect and there are value from the placeholder. If user inputs something and we don't know what about it, we're going to ask qualification, etc. So sometime on constitution, well, when you're working on a vanilla project, you don't need to be very specific. You just go with the flow. So that's the first step. And then you have seen probably here that at the top of the file, you see something called the handoff. So the handoff is like kind of the hit at the end of the, once the agent has run, once the constitution agent has run, I can hit a button, it will be build specification. So here you know that you are going to build something as a next step. Once you establish the core principle, you go to the next step, which is implementing specification for what you want to do. And remember, I was showing the specification template here, getting the user story, etc. Well, guess what? That's what we have here. So the specify, it will create the feature specification from a natural language feature description. So if you see a little bit how it behaves here, understand under the cover what this agent is doing. This agent is basically taking those arguments, so taking the user inputs and then generate a concise short name. And this is where we have most of the companies that say, no, I don't want to behave this way. I want to have another name. So here, the way it generates a branch, a feature branch name, basically it will analyze the feature description. It will do all of these steps. Here it will check if there's already an existing branch with that, and it will find the right name for the branch. And then once it creates the branch, it's going to run those scripts to create it, verify that that is created, and then you are loaded into the branch where you are going to load the template and fill the requirement for you. So that's really the bare minimum and how we get started, how we got started with it. So really, we have no idea. We can just do spec kit constitution and we can ask it anything and let's see where it takes us.
I think that's really wonderful because yeah, if people don't have anything or don't know what they need to do, it's all there for them, and it's, you know, it comes from best practice. It comes from the feedback of all of those contributors who really care about getting the best possible practice in there. But if they do know, if they do have a specific thing that is different than that, then they can just edit that right in there.
Yep, totally. This is one of the first, so one of the things I've done with when a customer, they say, look, Arno, we don't want to create a branch with the name of the technology whatsoever. Our first step in our development process is to create a Jira ticket, right? It's the source of truth of everything in the company. And this is fine. There's many products on the market that we see nowadays. So we can totally do that. And here you can ask Copilot to tune that. And now if you do that, I say, I want to modify spec kit behavior. So here you see I'm in agent mode and I'm just the vanilla one, and I say I want to modify spec kit behavior. So each time we implement a feature, we ask for a Jira ticket number, connect to Jira MCP to fetch the details. So now I'm not executing anything of spec kit. I'm just asking spec kit to be modified by the agent mode. So we are actually modifying the behavior of the agent. So guess what? Once be completed. Then the next time I'm running speckit.specify, it's going to ask me, hey, Arno, happy to implement that feature for you. However, what's your Jira ticket number? So that's exactly what you use. This is a library of stuff, and you use it to make things work for you. Very often, people say maybe SpecKit is too complex, maybe some interim artifacts, I don't want it. That's totally fine. I mean, make it work for you, and you need to make it work for you. You see here, I only have the agents that are really the simple project implementation agents. But as we go, I will have expert agent with skills, as we mentioned. Do you know the one that we created previously, where we were in the technical step? We can import them as well into the repo. And it could be done in many ways. It could be imported. It can be brought in by GitHub Spaces. It could be brought in by the organization. But I'm just showing you now that with local, you have a simple way to have them on the repo. And you know, it tells you now, okay, I've modified SpecKit, so the agent will now ask you for a ticket number, ask it and connect that and do that for you. So I have modified the product so it follows my my dev lifecycle. That's super important for me. It shouldn't change too much the way you operate, but it brings enough interest, like tracking what has been done, tracking the design decision, keeping the spec within the same repo so you can come back and you can adversely ask Copilot, hey, does the spec really fetch with what we've done or not in the past? That's really what I think is super powerful here.
But the more magic I see you do, the more I think about well, a concern that we hear a lot is loss of control, especially from senior engineers, and they worry about everything getting away from them. And so where do humans have to stay in control, and even as agents continue to get more and more capable?
Well, there's many ramifications on that, right? And so you have to hear what they mean by control and what they mean by staying in the. So for me, what's really important is all humans are always in the loop, because unless in a company you are committing directly to your main branch, there's still going to be a process of pull request, right, to validate your change. So, you know, think about it. When you create a pull request on GitHub, and you can ask GitHub Copilot to code it for you, or you can ask Copilot to validate the pull request for you. So he's going to check against quality, against security, and all this kind of stuff. But what's important, it's never an approver pull request. There's always a human in the loop. See what I mean? And you can always go into your GitHub repo config and say, look, anything that is changing on this repo, on this path, it needs to be approved by a code owner of the organization. It needs to be approved by 2 maintainers, or whatever you define in your branch rule set. So that's for me very fundamental. Is there's never the AI going to have their own life. And of course, we all seen the scare, right? Of oh, we have the agent; they can do anything on your machine. But when you customize the agent, actually, there's one thing that you can do as well. Is you can say, look, you are an agent, and here you specify the tools that you have available are the following one, and you can configure which tool it has access. So if you say you only have access to this MCP server, you only have access to this file in read mode, and you cannot execute, then the story is solved, right? So that's so many ways to stay in control. Now, in control can mean as well being in control of the code base, saying who can do what. That I believe a little less. I have sometimes the request, how can I do agents for a junior developer or for a senior developer? I'm like, well, that doesn't matter. If you can afford both, make it the best, right? So your developer can focus on something else.
I was I was teaching a class for some students yesterday about the AI fundamentals exam, and we were talking about responsible AI. And when I was explaining to them to the point that a human is always accountable, that you cannot blame the AI for stuff. and we were talking about autonomous vehicles and crashes and stuff like that. But in the scenario that you're describing, the GitHub Copilot agent is reviewing the pull request for you, but it is a human that is approving that pull request in the end. And of course, if you are lazy and you just trust the AI, you just click approve without really paying attention. You just say, well, it's done the review, it's all good, I approve. And this is fine. In most of the cases, it has reviewed accurately and better and with more attention than a human, and so it's all good. But in the case that it is not good and something is deployed to production, oh, the lights have gone off.
Yep.
And something is deployed to production that did not work and went horribly wrong, it's not going to be an excuse to say, well, the AI said it was okay. The person that pressed the green button is the one that will be responsible. So, yes. If a human is going to stay in that loop, they need to stay in it responsibly. They need to pay attention. They need to work with the AI, not just drop everything to it.
Yep. And I would say as well, to be honest, what we've seen is, with the introduction of GitHub Copilot coding agent, we see on many repo an overflow of newly generated code in many companies or even in the open source. So to deal with the amount of source code, you're going to use AI, you're going to use Copilot Code Review to review the code against industry best practices, code quality, against your own standard. You can define your own pull request criteria of review. And then, as a PR reviewer, as an approver, you can always have a better informed decision when you click approve, because you have all those criteria that has been required. And some point that we didn't mention so far is Copilot has been super helpful for me and many customers on improving the CI/CD, because we all had this embarrassing situation where we have 50 commits before anything run into a CI/CD. I think we've all been there. Now with Copilot, it helps so much with the syntax of the GitHub action or any type of CI/CD that you can very confidently improve the quality of the software. So to me, it's really a win-win situation going there. AI will generate more code for sure, but it will also be a super useful tool, if not the only tool, to help you make an informed decision as a developer. And ultimately, you are in control, but with much better and less guesswork than you had before when you were approving a pull request.
There's a story I tell all the time. It's really one of my favorite ones, that a friend of mine works over at one of our big mining companies, and he said he was coding with Copilot and letting it fill in all the boilerplate and, doing what he was going to do anyway, but a lot faster. But it reached a point where it coded a specific block differently than he wanted. And so he said, no, I don't want that. I want it to be like this, and recoded it. And it said, I can't let you do that because that coding it that way is going to introduce a security flaw into your app. And then this is the way that it is now recommended that you code it. And it explained it all to him. It showed him it brought all its receipts to say this is why. And he said he was blown away because he didn't think an AI was going to teach him with 30 years experience how to code, but he absolutely acknowledged there's no way he can stay on top of all of the updates and all of the changes that come down. And the Copilot knew. And so it explained it, he accepted it. And it is a good check and balance. And those checks and balances run both ways. We have to be a check on the AI, but it will also help us.
And also, since you mentioned security, I think it's an important topic as well, that you can influence the generation of the code, and it will give you this feedback as you just described. But overall, it's still LLM, so it's still a non-deterministic process, right? So some company, they say, look, I still want my code to be thoroughly reviewed against best practices in a really not a statistic, but in a deterministic way. And this is where you see that now, for instance, if you're using Copilot coding agent inside GitHub Enterprise, now we run security check as well. And with many enterprises, we're going with GitHub Advanced Security, which, of course, there's going to be all the magic of AI coming. But at the end, you have GitHub Advanced Security, which will do the static code analysis, will review every single line of your code of your repo, gonna make a very in-context decision of it and tell you, no, this is not good. It doesn't work. And by the way, it's not going to tell you it doesn't work. It's going to tell you, hey, this is the auto fix I produced for you for it to make it super easy to implement. So because we want to have both sides, right? We want to have deterministic implementation, but we really want to be 100% sure that it has been scanned. Usually we use that in great collab with GitHub Advanced Security.
I do think like the holistic nature of the platform is one of the things I find most compelling. You know, in that absolutely there is that flexibility, there is that choice. If you want to choose whatever model you want, whether it be, you know, whether it be one from this vendor or an open source or whatever, you can pick. And you can absolutely go to other platforms, as you say, like Jira or whatever. You can map everything out. It's all good. But if you do choose to do everything within GitHub, use your GitHub Advanced Security there, use your models there, use your GitHub coding agent there, use all of the things, then you have really like more peace of mind around that security, governance, compliance, and privacy, because you know it's all stitched together really well with those things front of mind.
Totally, Michelle, super good. Maybe I just want to take you in another quick demo. This one I recorded before. I'm just going to show you because it takes a bit of time to execute. So just want to show you a pre-recording.
Okay.
Okay, Michelle. So you see now we're in the demo that I prepared before, and we can see that same thing we do we do a specify init demo. That's a previous demo. We pick same thing. We pick the agent. We pick everything we want. We get into the IDE, and we see that we do the spec kit constitution. And here, I didn't even fill anything. I just say constitution, create it. I don't know. I don't care too much. Just create whatever you need to work. And it created for me the reasonable choices for the management of this product. So now it tells me that the next step to do is to do a spec kit.specify. In the newest UI, it's a couple of weeks ago I recorded this, but now you would just pick the agent. But you see, we're still here in the slash command, so slash spec kit.specify. And you can see that I'm trying right now to recreate the Spring Boot veterinary doctor and pets management system. So what I do is I do spec kit in specify, and you see that I give very little definition. And out of that, we really use one of the super interesting aspects of LLM, which is break down into your content and review what it means. So out of remember the spec template I was showing you a few minutes ago, you see that now it created my user story, and the user story would be create a new client, register a new client and pets, and it created, okay, user story tree, record visit information with priority number, etc. So it already put some intelligence at work to know that, okay, into all the user stories that are generated across your very simple requirement, we can see that it created a prioritized user story list here, and we have 20 functional requirements out of that. And you see that it actually is suggesting me that next step we might want to do clarify to disambiguate a couple of the steps. So when I do clarify, it will ask me questions and say, look, those are the specs, this is what you want to do, but there might be a couple of ways to do this thing. So now, what do you want to do for user authentication and access control? So it's offering me things like, okay, no authentication, or simple passwords-based authentication, or RBAC with whatever, or multi-factor authentication required for all users. And I'm like, well, I don't know what you mean, but I know that at Microsoft we have something called Entra ID B2C that can allow me to do such things. So can you use Entra ID B2? See? And how do you use that? So you see, I'm now adding, in a very natural way, I'm adding requirements. And then what it means is it's going to continue to ask me a couple of questions to know what I want to do. And in the next step, it's going to try to make sense of it, to match the requirements that I want to give in all the answers that I've given. So now it's telling me what data retention do you want for the pets, what search performance are you looking for in the records, etc. So we completed the clarification in this step, and we see that we have a couple of things that are cleared. And now it's telling me that the next command is to do a spec kit plan. And as the name say, plan will basically continue to do further investigation on what you give by basically breaking down those user stories with the additional requirements and understand how technically it is feasible and how is it going to look like. So again, a long story short. Here I recorded that and shortened it for this demo because real time it was 2 hours. So I don't want to take 2 hours for the recording of that together. And you see, it's processing, it's working, and eventually we start to have more artifacts that are here. So remember when we were talking about keeping a trace of everything that was done in the process? Think about the past, right? You're always wondering, why did they make this technology choice? Why did they go there? Why did they use that? And here you see, if we look at the processing, we're going to see that, hey, in the tech stack requirement that we have, we picked that we are going to use .NET 8 with ASP core. We're going to have React 18. And because basically I didn't specify any requirement, I would have said, yeah, I want it to be full .NET, I want it to be full Java, whatever. It would have produced it the same way to me. But now, based on the concept that I give, it did an investigation and said, look, in .NET 8, in C#, the Entra ID B2C framework is working super great, so let's do that. And you can agree or you can disagree with that. I mean, now you're still in the spec kit step where you can say, look, why are you using .NET 8? Because it's fairly old. Maybe you want to switch to .NET 9 or 10. So you use the chat and you will capture that, and it will check again if that's working or not for you based on the spec and everything. So it will reanalyze the new inputs with whatever you want. So here you see I fast forwarding and it creates already artifacts around the API. So it already created the openapi.yaml with the specs of how I want my app to be responding in terms of API. So it's already written there. So out of that, then comes the fun part, which is implementing that. But remember, in SDD, you spend most of the time, and it's a bit counterintuitive, but you spend most of the time writing the spec, iterating on the spec together. So you see that now I did the other spec kit task breakdown. So now when we are at the spec kit task breakdown, what we're going to do is really taking all the steps that I need to fulfill to achieve that objective that is determined into the plan, into the research, into the spec that we created, into the open API. So it's going to break down that, okay, for this set of things, you see that I have 9 tasks for setup, project initialization. There's 12 tasks I need to do to create the really, really fundamental like auth, database, middleware, etc. There's 58 tasks for the search, the view medical history, 51 tasks for the registration, etc., etc. So we are, Michelle, very far from fancy vibe coding with like a tiger flying in a circle on fire. It's because it's really professional software engineering. It's really breaking down, doing the planification, right? And it takes time. I can see you have the image in your mind, maybe.
Yeah, I'm just. I hadn't imagined there being a fancy flying tiger in the vibe coding.
So you see, now I'm just spec kit / implement, and that's the last step. When I do spec kit / implement, then it's gonna code. And you know what? Maybe I'm gonna like what I see in implement stages. It's gonna take time, but maybe I realize after all, I don't like this thing. I want to start everything over in whatever other language. Then I just trash the code that it has produced. I still have the spec. I just reiterate on a little bit that I want to use a different framework, for instance, and I can restart and I do a spec kit / implement. And that's just the language, the platform, etc. It's just a small detail at the end. So here, that's what we're able to achieve. So after a while, you see the breakdown, the task, and you see, okay, I can see the Swagger already where I have my API visible. That's cool. And then I have my ugly interface that is here. Because I didn't specify anything too much, but I could have specified use this framework for the front end, use MCP to test it and make it better. But for now, I just wanted to, getting out of the door, showing that after a few hours, it created something that is properly architected and engineered. I have my APIs, I have my backend, my front end, all of this thing. And while we were talking, it was basically executing step by step the task, going through the task and making sure that it didn't miss anything. And if you go back to the task.md, you can leave it somewhere and you can come back after and say, okay, continue the task where you left it over. So that's what I love about SpecKit, is really putting things into a much more ordered, deterministic way. You see, in a really good structured approach.
Is it enterprise organizations that are generally using this, or is this for everyone?
Yeah, I would say when you're going this way is because you are more in an enterprise context where you want to keep the history, the track record, when you want to collaborate with other teams to approve the spec. You see, one of the aspects of also having the spec documented here and the plan is that you can use that as an iteration as a team. Because once it's checked out on a VCS on GitHub Enterprise on a repo, you can have somebody check the code. They have the same agents from SpecKit, so they can reiterate on that and ask more questions, add more context, add more thing. And you open the pull request, and this is how you have the living specs. So this is really wonderful for enterprise collaboration and evolution of the software development lifecycle. As a normal individual developer, there's probably a lot of interim artifacts that honestly I don't bother too much to keep, right? As a vibe coder on the project I do on the weekend. But as an enterprise software development, that's definitely the kind of thing I want to do.
But if you're an individual developer, you would be looking at this so that you could learn it and so you could understand how to implement it and operationalize it in an enterprise business. And that would make you a very marketable developer in case you were wondering what you should be learning.
Spot on. Instead of creating a really bad vibe coded stuff, now it's really structured as a professional developer would do it. So it's super good to learn.
Yeah, excellent. Okay, so I think that we have probably shown people so much that they just want to get into it now and try it for themselves. But just to close off, looking ahead, what do you think developers need to focus on more? Is it writing better code or is it writing better specs?
I think you have an idea already where I'm getting, right? I think AI will write a very good code for many situations. For some situation, maybe corner cases is not, but for the vast majority of any project, you see the coding works super well. So really the difficulty is getting the right context, getting the right amount of detail so that AI knows exactly what you want and the way you want it. If you see, right, the realm of possibilities you have with Copilot in the agentic mode, everything that we do with SpecKit is to drive it. So it's a powerful engine that goes into one direction, explicit everything. So you're really able to steer it the way you want to go with your constraint of an enterprise, with your constraint from the business. So the way I see many people evolving is like the developer doing much more stuff related to the business, much more closer, working on perfect or very good spec, and be iterative with the spec. All the thing comes together pretty neatly with things that produce a nice UI. If you see like GitHub Spark, that allows you to do fast prototyping. Fast prototyping is good to sell it to the business, but then working on the spec, detailed spec, iterate with the spec. How do you put things to work on that? Find the right exact way it should work. I think that's really the talent is work with that to make it work for every company.
I suppose people will probably say to me that the two things are inseparable, but it's not really true. But being able to read code and understand it is perhaps more important than writing it, because the agent is going to write it all for you. If something goes wrong and you can't read it, you can't understand why it's not working, it's going to take a lot longer to unpick that with an agent than if you knew what you were reading. So keep reading it, keep learning it, keep understanding it, but use that to learn how to guide it better with better specs, I guess, is our advice.
Very well said.
Arno, thank you. This has been a genuinely practical playbook for shipping in an agent-powered world. And I want to thank everyone for joining us on New Breakpoint. All the resources that we have discussed and a few extra ones will be shared after this session. And we will hang around for the next 10-15 minutes or so, answering your questions in chat. So do put those in there. Thanks everyone for joining us. And thank you, Arno.
Thank you so much, Michelle, and everyone.
We hope you enjoyed this digital event. We have specialists on standby to answer your questions for a short while. To ask a question, type it into the chat window now and we'll get to it as quickly as we can. If you're not staying for the Q&A, thank you for attending and we hope to see you again soon.